Hi, I'm Sejahtera and good evening everyone. Welcome to Pusat Tuisyen Akademi Youtuber with joint venture of e-Didik Malaysia and Grab Guru Malaysia. I'm Mr. Peh. Currently, I'm teaching at College Tingkatan 6 Tempatan Melaka. I am the on-duty teacher for this week. For information, Akademi Youtuber Malaysia Panitia Fizik is prepared for you 2 free online classes. So from the screen, you may see that the Form 4 class, which is in DLP, is held on every Sunday at 15 p.m. So another class will be Form 5 for Non-DLP. The class will be held on every Friday, 9:30 p.m. So for this week, I am going to continue the Chapter 2, Force and Motion 2, Force and Motion 1. So with subtopic of 2.3, free fall motion. The class will be expected finish within 1 hour. And the link schedule for today's lesson will be sent to the chat room at the end of the class today. So please fill out the link within 30 minutes. And you may fill out the link with any email you are available. Okay, so without further ado, let us start our lesson today. So in today's subtopic 2.3, free fall motion, we are going to learn about 3 learning standards. Okay, so for first learning standard, you need to able to explain the examples free fall motion and gravitational acceleration. Okay, so firstly, let us look at the meanings of free fall. Okay, so what is a free fall? So free fall refer to the motion of an object influenced solely by force or gravity, and the air resistance can be ignored. So you can just look at this figure. So the object is only added by force or gravity, which is also can known as weight, because the weight with symbol W can calculate by using formula M times G, where the M will be the mass, G will be the gravitational acceleration. Okay, so in practice, free fall can occur only in vacuum. So where air resistance is absent, the absence of air means that there will be no any air resistance to opposite the motion of an object. Okay, so number 4. Okay, so you can look at the GIF here. So in a vacuum, both light and heavy objects are fall freely with the same gravitational acceleration, which is the acceleration caused by the force of gravity. Okay, so gravitational acceleration is the rate at which an object speeds up due to the gravity pull, commonly represented by the symbol small letter g. So the magnitude of gravitational acceleration is approximately 9.81 meter per second square. Okay, so here we have a condition. So when the ball is released, you can just look at the picture. Okay, so a ball is released by a man. It starts with the 0 velocity. So at t equal to 0, so the v is equal to 0. So as it begins to move, it undergoes free fall. So showing that it is accelerating due to gravity. So you can see at the per second, due to the gravitational acceleration, so the object will be moving at the velocity of 9.81 per meter per second. So for the second second, so the velocity is increases with 9.81 times 2, which will be equivalent to 19.62. So from this consequence duration, you may see that all the velocity is increases due to the gravitational pull. And the gravitational pull for the Earth will be cause the G equivalent to 9.81. So every second, the object will be have increases velocity with about 9.81 for respective second. Okay, so number 8, gravitational acceleration is independence of the mass of the moving object. So that means that if you're using the heavier object or lighter object, so the speed will be increases with the same value, which will be 9.81 meter per second for every second. Okay, so on the line we have Chia-Ying. Okay, so thank you, Chia-Ying, for joining my class. Okay, so for next, okay, so we discussed about the object fall in the atmospheres. So where will be presence of the air? So this is what the actual situation we observe every day. Okay, so here, in the presence of air, an object experience air resistance, which opposes the motion. So you can see when we drop an object, definitely the object is moving downward. So the air resistance will be added at the opposite direction, which will be at the upward direction. So this will be different with the free fall motion just now we explained. So where the object is just influenced by the downward gravitational pull, which is also give with parameter of weight also. Okay, so air resistance occur when an object moves through air and collides with the air molecule. So when the object moving down, so it may collide the air molecule. So the air molecule, it hits, the more air molecule it hits, the greater the force of air resistance. Okay, so generally, air resistance, it depends on the velocity of an object and also the surface area of the object. Okay, so as an object's velocity increases, the air resistance adding on it also increases because there will be more molecule going to hit by the object. So the air resistance will be increases. And this may cause the net force decreases. So the acceleration will be decreases actually. Okay, so here, the second factor will be the surface area. So increasing the surface area of an object will increase the air resistance added. So here you can see we have two conditions. So with air will be the one where you can see in the real life. So the stone will be dropped faster than the paper. However, if in free fall condition, will be only occur in vacuum condition. So the mass of the object will be not affecting the which object will be going to drop. So they will be dropped at the same time. Okay, so on the line here we have Cikgu Hasnitah. So thank you, Cikgu Hasnitah, for joining my lesson. Okay, so here will be the discussion between the different of the object free fall in the atmospheres. So that means it's in our real life or presence of air, together with the free fall in the vacuum condition by using a stone and a paper. Okay, so for air, we mainly discuss about the stone and the paper release at the same height simultaneously in the laboratory. So that means you'll be in the real life condition. Okay, so here, what you may observe, you can see from the GIF, DGIF. So the stone is fall faster, fall faster than the paper. Okay, so why? So here the reason will be a bigger air resistance added on the paper. Okay, it has a larger, because it has a larger surface area. The gravitational force of stone is able to overcome air resistance better than paper. Okay, so here the stone, they will be have two forces added. So the gravitational pull, where will be weight added downward. So at the same time, they will be have air resistance added at the opposite direction. Okay, so the air resistance may decreases the velocity moving downward, or the net force, overall net force can be decreases. So we can using the Newton's second law to explain the situation where F equal to ma. So when the net force decreases, so the air here will be the overall acceleration decreases. Okay, so this will be happen for the paper. So because the paper have a larger surface area, the air resistance will be greater. So the net force added on the paper will be decreases, causes the overall acceleration decreases. So you may see the speed moving down for paper is decreases. And on the other hand, the stone will have a smaller surface area. Okay, so the air resistance added will be smaller. So the overall, for stone, the overall net force is actually higher. Okay, it's actually higher. So the air acceleration added on the paper is actually greater. Okay, so this statement tells us that the gravitational force of the stone is able to overcome. So because the weight of the stone is also bigger, so the air resistance overall added, although it will be is actually smaller because of the area is smaller here. Okay. Okay, then the B situation. So the same stone and paper are put into the vacuum tube. Okay, put at the vacuum tube. Okay, so and then drop simultaneously from the same height. Will be same as the way how we do at experiment A. Okay, so from the GIF, you may see that both of the object will be dropped at the same time. Okay, because at the vacuum condition, both of the object is free fall. Okay, it's free fall, so there will be no any air resistance added at the both objects. Okay, see, the observation will be both objects reach the bottom at the same time. So explanation, in vacuum, there is no air resistance. The only force adding on both objects is the force of gravity. Okay, so both objects free fall with acceleration due to gravity, despite the differences in their mass and shape. Okay, so this will be the activity, first activity. Okay, so now we go for the second activity. So here the aim for the second activity is to study the relationship between an object surface area and the magnitude of air resistance. Okay, so from the first activity, we actually can know that if the object with bigger surface area, just like the paper, just like I show you, the air resistance will be higher, added or experienced by the object. So the overall net force will be smaller, causes the acceleration decreases. So the object will fall at slower speed. Okay, so for A, the activity will be like this. Hold the golf ball and a piece of paper, golf ball with this and paper with this, at the same height and drop them simultaneously. Okay, so what is the object expected reach the ground first? Okay, so here it should be golf ball, right? Because just now we have learned already, so the surface area bigger for the object and cause greater air resistance added. So the paper here have a greater surface area. So the air resistance added is actually bigger compared to the golf ball where the surface area is smaller. So the air resistance will be smaller. So the overall downward force or the net force is greater for the golf ball causes it have a greater acceleration added to golf ball. So the ball will be fall faster compared to the paper. Okay, so the first question, which object reaches the floor first? So as mentioned, there will be golf ball. Okay, so reason. So the paper has large surface area. As such, the air resistance adding on it is greater. Okay, so the experiment is repeated with the same golf ball and paper, but the paper now is scrambled to the size is almost same as the golf ball. So again, the question might ask you, which object reaches the floor first? Okay, so here, just now we go through already. So for the air resistance added to an object, it is affected by surface area together with velocity. But here we discuss about the surface area. So both have the almost same surface area. So we expected both ball and paper, which is scrubber, will be drop and reach a fall at the same time. Okay, so the reason, as mentioned, because both objects have the same size and same surface area. Therefore, the air resistance added to the both object will be the same. Okay, so the mass does not affect the gravitational acceleration, although here the golf ball have a greater mass. So through this activity, we may conclude that the surface area for an object increases, the air resistance will be increases. So the object will be reach the ground slower. And second, the mass of the object will be not affecting the gravitational acceleration. So the gravitational acceleration is actually influenced by the strength of the gravitational pull of the planet. For example, the gravitational pull for Earth is greater than the Moon. So the gravitational acceleration at the Moon will be expected smaller compared to Earth. Okay, so here, this will be another observation. Okay, so here we observe the object of heavy and light object in A. Okay, so for just now, the object weight is actually, I mean that for the golf ball is higher compared to the paper. However, now we discuss a situation where one of the object is actually far heavier compared to another object. Okay, so here we're using elephants together with the feather. Okay, so look at the first sentence. So in diagram, an elephant and a feather are dropped at the same time from the same height above the flat surface. So the elephant accelerate faster than the feather. This is what we suppose expected. Okay, so that means that the elephant will be fall at the first. Okay, so light object accelerate more slower than a heavier object when other forces such as air resistance act on them. So this is also quite similar to the situation just now I explained to you. So where actually here we want to discuss about the net force for heavy object, definitely the downward force W, we're using W as a downward force, which is a gravitational pull. So the air resistance will be added outward. Okay, so because of the air resistance, we have the smaller net force. So the net force where we can relate to Newton's second law will cause us the overall acceleration decreases. Okay, so the object with smaller weight will be have smaller overall net force because the air resistance will be give significant impact to the object. Okay, so here, therefore the light object such as feather does not experience free fall. You can see at the first second, the feather downward force is actually greater compared to air resistance. So that means the feather is still accelerate with higher speed. Okay, however, when go for second, okay, so the air resistance is almost same as the force of gravity, so that the feather will be slowed down because the overall net force decreases already. So the air added to the feather decreases. So the feather will be moving slowly downward. So we can conclude that for the light object, they will be not experience free fall in A, I mean in A, but in vacuum, the both object definitely will be dropped at the same time. Okay, so the number 4, if the object is very heavier, heavier such as a stone, or here we have an elephant as a example object we explain here. Okay, so 4 in the gravitational field were so where air resistance can be ignored, because here you can look at the first second. Okay, so look at the first second. So the gravitational force is greater compared to the air resistance. So although at the second, so we have an increase of the air resistance added to the elephant. So the magnitude for the upward force is still far smaller than the downward force. Okay, so here the elephants will be still, the elephant downward force is still not affected by the air resistance. Okay, so in this case, the heavy object, although the surface area is bigger, okay, so the overall air resistance will be not give significant impact for the net force. So we can say that the heavy object can consider free fall in the atmospheres. Okay, so conclusion. So the elephant will be fall because the weight or the downward force, which is a gravitational pull, is far larger than the air resistance, although it has a bigger surface area. Okay, so this is a third activity where we discuss about, although the heavy object have a bigger surface area, however the air resistance impact will be not significant added to heavy object. So the heavy object will be still considered experience free fall in atmospheres. Okay, so here let us go through one checkpoint question related to the learning center 1. Okay, so here the question will be like this. Diagram 5.1 will be this. Shows a coin and a feather are dropped simultaneously. Simultaneously, that means they drop at the same time. So from the same height. So they are both drop at the same height first. Okay, then for the diagram 5.2, Okay, so coin and feather also drop at the same height, but is in vacuum condition. Okay, so that means that we are very confident, say that the object at diagram 5.2 is in free fall condition because there will be no any air resistance added to the object. Okay, so the first question here will be asked about the meanings of free fall. Okay, so from the first slide, actually I already tell you that the definition for free fall. So there will be the falling which is affected by gravitational force only, and the air resistance can be ignored. Okay, so you can just write as this sentence: falling is affected by gravitational force only. Okay, then here we have the second question. Okay, so the question for this example question is example question for paper 2. Question number 5 is a conception question where you will see two diagrams, and we want to do the comparison between these two diagrams. Okay, so the second question here will be ask you to state the type of motion of the coin and the feather. Okay, so in diagram 5.1 and 5.2. So in both situations, the object is actually added with the gravitational pull, right? They will be using W, right? Gravitational pull. The difference here just for diagram 5.1, they will be have another air resistance added upward. Okay, so the both situation, the object is experience same G as both experiment is conducted on Earth, so that they have the same gravitational acceleration. So the motion here will be have constant acceleration as the G on Earth, as mentioned, will be 9.81 meter per second square. Okay, so that means that the motion here will be constant acceleration. Okay, so the next question here, B. Okay, so based on the diagram 5.1 and 5.2, compare the falling time between the coin and the feather in A. So that means in A, we just need to compare in the diagram 5.1. Okay, so in diagram 5.1, we are very clear that the coin will be fall and reach the ground first compared to the feather. So that means the falling time for coin will be greater than the feather in A. Okay, so the falling time of the coin is shorter, right? Because it's faster, right? Just like I mentioned. So the falling time for coin will be shorter. You can using this symbol, than feather. Okay, then the next question will be asked about the falling time between the coin and the feather in vacuum. So you can see both objects where will be only added with gravitational pull, so that they will be reach the ground at the same time. So the falling time for coin will be equal to feather. So the sentence answer will be the falling time of the coin is same as the feather in vacuum, or you can using symbol equivalent. Okay, as your answer. Okay, then the next, the surface area between the coin and the feather. Okay, so surface area, if you observe the surface area between the feather and coin, definitely the feather will give us bigger surface area. Okay, so the surface area of coin is smaller than feather. Will be the answer. Or you can using a symbol smaller like this. Okay, then the number 4, we discuss about the air resistance. Okay, from the theory just now we learned the air resistance is affected by surface area. as the surface area is greater, so the air resistance will be greater. Okay, so from the observation of the surface area in both diagram 5.1 and 5.2, so the feather have greater or bigger surface area. So the air resistance will be higher for the feather. So answer, the air resistance exerted on the coin is smaller than the feather. We can see the air resistance added on coin is smaller than feather. Okay, you can using symbol less than. Okay, and the last question will be ask the relationship between the surface area and air resistance based on your answer in B3 and B5. Okay, so the surface area increases, the air resistance will be increases. So here, or you can give the vice versa answer here. So the smaller the surface area, the smaller the air resistance. Okay, so this will be the reference answer for this question. Okay, so the last sub question for question number 1 here will be diagram 5.3 shows the skydiver falling downward before the parachute open. Okay, so explain why the skydiver opened his arm together with leg. Okay, so why the skydiver opened his arm and leg when falling, as shown in diagram 5.3 here. Okay, so if you able to relate the theory just now we learned, so here when we open our arms and legs, so the surface area will be increases, right? So when surface area increases, the air resistance will be increases. So the skydiver will be falling down at slower speed. So this is what actually the purpose of open up the arms and leg for the skydiver here. Okay, so here we have 2 marks. That means that you have to give 2 points. So the first, as mentioned, will be increase the surface area. So the air resistance will be increases. So the skydiver will be moving downward with slower speed. Okay, so before we go for our learning standard 2, so we may take 5 first. Okay, so please come back about 1 minute. Okay, so welcome back everyone. So let us continue the learning standard 2. Okay, so for learning standard 2, you must be able to understand the experiment where to determine the value of gravitational acceleration. So as mentioned just now from learning standard 1, so the value of the gravitational acceleration will be about 9.81 meter per second square. Okay, so now we want to discuss one of the experiment in your textbook at page about 48. Okay, so is how we determine the value of gravitational acceleration. Okay, so first in physics laboratory, gravitational acceleration G can be determined by using the acceleration of a heavy object such as weight or steel ball. Okay, from the slide just now we have go through it. So if using the heavy object, so the heavy object where have a higher weight may reduce the significant impact of the air resistance on it. So the object or heavy object falling down can consider as the free fall motion. Okay, so here we have actually two methods to determine the value of gravitational acceleration or G actually. Okay, so the first we using the Tingkatan. So where you can see at this picture, so we have using the weight and attached together with the Tingkatan. Okay, so when the object moving down, so we may get the Tingkatan with tick on it. Okay, so this will be in the condition of constant acceleration. So we expected the distance between two dots will be increases lah. Okay, and then the G you may calculate by using the formula V minus U over T lah. Okay, so how you can get your V? You can using three method actually, where you learn already at 2.1 or 2.1. Okay, you can using one tick, the first tick over 0.02, right? Then you can get your U. Then the last tick, you can just measure the distance, divide 0.02, then you can get your V. Okay, then T will be, you have to calculate, you have how many? Tick minus 1. Then you can multiply with 0.02. Okay, so you can get the answer already. Okay, however, we are going to use second method. Okay, we are going to using a second method for determine the gravitational acceleration. So the second method here will be known as a photo gas system. Okay, so this is a photo gas system. Okay, so why we using the photo gas system? So because the photo gas system is more accurate compared to the Tingkatan method. So that means experiment I'm going to discuss with you here will be using the photo gas system. Okay, so first, no friction affecting the motion of the trolley. Okay, because here, okay, so here, no friction here actually is, if I say motion of the trolley, that means we're using the going down slope where we want to find the motion of the trolley. But here, the friction can be when the Tingkatan passing through, okay, passing through the Tingkatan timer here. Okay, so that means here we also can reduce the friction because when the steel ball drop, they will be not touching any surface and they will be passed through the first photo gate and second photo gate. So this will be more accurate for our reading. Okay, then second, the high accuracy of the electronic timer will be this. Okay, so for Tingkatan timer, one tick, there will be about 0.02. So for electronic timer, the accuracy can up to 3 decimal places here, which is 0.01. So that's why it is better we're using the photo gate system to determine the G here. Okay, so here this will be the experiment 2.1, where is quite similar discussion you may find at the textbook, page 48. Okay, so here, the aim of the experiment is to measure the Earth gravitational acceleration, G. Okay, so the arrangement will be just like this figure. So the apparatus and material in this apparatus, arrangement, you may see there they have a photo gate system. Okay, photo gate system and electronic timer will be this. So electromagnetic release will be here. Okay, they have a steel ball, okay, together with the container. This container, we are going to catch the steel ball release. Okay, so at the t equal to 0, so the steel ball will be start to drop at the top. So there will be at certain period, the steel ball will be reach the first photo gate. So where can known as T1 here lah. So the T1 will be shown at the electronic timer. Then the ball will be continue drop at the second photo gate. So the time when the steel ball reaches second photo gate will be T2. Again, will be shown at the electronic timer. Okay, so here will be the procedure. So the first set down the apparatus as shown in diagram will be this lah. Okay, so position of the second photo gate so that it is 30 cm away from the first. Okay, so this is a position at the first photo gate. Okay, so the distance between both gate will be 30.0 cm. Okay, so ensure that the steel ball can fall freely through both photo gate. Okay, so here, as long as we not touch the height adjuster, so there will be no any friction when the steel ball moving downward. Okay, so this will be just like this figure. So the object must be passed through the photo gate, then only able to detected and show the time and the electronic timer. Okay, so this will be the value shown at the electronic timer. Okay, so release the steel ball using the electromagnetic release here. Okay, so record the time at which the steel ball passed through the first photo gate, so where we can know as T1. And the second photo gate, so the ball we release, reach the first photo gate, the time will be recorded at electronic timer. Then when the same steel ball reach the second photo gate, so the timer will be recording the time also. Okay, so this experiment I repeated with distance. So next will be we want to adjust the distance between the first photo gate and second photo gate to 40.0, 50, 60, and 70. Okay, so that means that you have another set of T1, T2 value. Okay, so here, this will be the result, what we can get. Okay, so here, the H is actually the distance between two photo gates. So as mentioned in procedure, there will be 30, 40, 50, 60, and 70. Okay, and then T1, there will be the time when the steel ball passed through the first photo gate will be here. So the time will be recorded at the electronic timer. Okay, and then T2 will be when the ball drop and pass through the second photo gate. Then the G is a gravitational acceleration where we want to calculate. And we expected the value will be approximately 9.81, where it is gravitational acceleration of the Earth. Okay, so here, this is a reference answer. So where I get through the experiment. Okay, so you can see the T1, the time taken will be given as here. Okay, then T2 will be as here. Okay, so now so that means the T1, T2 will be your primary reading. So the T1 and T2 is actually the responding variable, right? So the H here will be the manipulated variable. Okay, so the G is what we want to find. So the G is actually also considered as our responding variable. So where we actually want to find out the value, where we're using a T1 and T2 value here. Okay, so here, this will be the concept. Okay, so to calculate the gravitational acceleration, actually we're using this formula. S equal to ut plus 1 over 2 GTS. Okay, so the G here is actually gravitational acceleration we want to find. Okay, and then this formula is actually the formula where you actually learn at 2.1 already. It's a straight line motion equation. So S is from actually S equal to ut plus 1 over 2 at square. So we just replace the A here to G because the object is moving downward, where the A here will be have same value as G. Okay, and then the U will be 0 because object is just released from the top position at electromagnetic release here. Okay, so when we substitute U as 0, then the T is a duration between T2 and T1. T equal to T2 minus T1. Okay, so you rearrange, you get this formula. Okay, so now I just show you the first reading. So where the H here will be 30. Okay, I want to get the value G for the first reading. Okay, then the T2 here will be 0.8 square minus 0.110 square. So you press calculator, you get this value, 9.73 for the reading I get. So that means quite close to the 9.81. Okay, so this will be the first reading I calculate. Okay, so again, you just substitute in this formula. So where the H now will be changed to 40. Your T2 will be 0.32 square minus your 0.13 square. Then you get this value and also the rest. Okay, so the value you get expected smaller a little bit than 9.1. Okay, because actually there is a upward force where the air resistance actually added, but it's very, very small and can be ignored. So you see the overall value is actually quite close to the 9.81. Okay, so here the conclusion we can make as the Earth gravitational acceleration is 9.81 meter per second square. Okay, then now number 4. Okay, so now we discuss further for the G value. Okay, so the value of the gravitational acceleration, where actually the average will be 9.81 meter per second square. Okay, so but it is depending on the location and also the altitude. Okay, so what is the meanings of this? Okay, so here the value G is greater at pole than the equator. So this can be explained by this figure. So here, actually our Earth is not a perfect sphere. So from this figure, so you can see the distance between the center to pole, the North Pole, is about 6,350. Then the center to the equator, here this is the equator. The distance is 6,372. That means the distance at the equator to center is actually further. further, right? Okay, so compare to the pool to the center, which is nearer. Okay, so you can see the value of G is greater for pool, which is more nearer to center. Okay, so that means if the position or the location which is more closer to center of Earth, the gravitational acceleration will be higher. Okay, but the two value is not showing significant difference. Okay, so this is the first. Then second, altitude. Okay, so here, the G is greater at sea level. Or here is the sea level compared to the higher altitude position. So here I'm using the Mount Everest, the highest mountain on Earth, right? Okay, so here, the higher position or higher altitude, the G value will be decreases. Here shows the value about 9.764. For sea level, the G value is higher, 9.80665. Is quite close to 9.81 already. So in the conclusion, that means that the value G will be showing slightly different when they are at the different location and altitude. So if the object is more closer to the center of Earth, the G will be greater. So this will be same for the altitude condition also. Okay, so however, generally the value of G we still assume as the 9.81 as the average for most of the location on the Earth. Okay, so we have finished already our learning center 2. So now we go for our learning center 3. Okay, so here, the learning center 3 will be the last learning standard for our subtopic of 2.3 today. Okay, so the learning standard here will be you should able to solve the problem involving the Earth gravitational acceleration for object in free fall. Okay, in free fall. Okay, so here the solving problem involving free falling object. Okay, so here first sentence. All object on Earth experience gravitational acceleration. G G, the value will be 9.81 meter per second square. So pulling them towards the Earth. Okay, so a freely falling object accelerate at the constant rate. Just now I showed already. So every second, the speed will be increases 9.81 due to the gravitational acceleration added to the object. Okay, so since free fall is a type of uniform accelerated motion, so we can use the equation of motion for uniform acceleration. Okay, what means by this statement? Okay, so at the 2.1, actually you learned already the equation of motion where v equal to u plus at, s equal to ut plus 1 over 2 at squared, and then v squared equal to u squared plus 2 as, right? Okay, so for this subtopic, we just substitute or replace the a to g. Okay, so the equation become v equal to ut, v equal to u plus gt from here. S equal to ut plus 1 over 2 gt squared from this equation. Okay, and then v squared equal to u squared plus 2 gs from this equation. Okay, so this will be the equation I'm going to use for the problem solving in the learning center 3 today. Okay, so here, before we go for calculation or problem solving, so here you need to know the sign of the parameter, whether it's positive or negative for different direction. Okay, so here in problem solving, we assume upward motion is in positive direction. So you can see when the object is thrown outward, So the value we assume as positive value or positive direction. Okay, so that means the distance or displacement will be positive. Velocity is also positive lah. Okay, while for the downward motion, it will be negative, as illustrated in the figure. You see, when the object is released downward, so the displacement will be negative, velocity also negative. Okay, so the value of G, gravitational acceleration, so the object all will be moved towards the center of Earth or moving downward, right? So that means that the value G will be always in negative. Okay, because the gravitational acceleration will be acts downward towards the center of Earth. So when in calculation, so you should always give your G value in negative. Okay, I just saw some comment from Jai, no? Okay, so how are you? Okay, I'm fine. Yes, you can try the question. So we actually got another two problem solving question, no? So Chen, you are welcome for trying the question. Okay. Okay, you can show your answer later on in the chat room. Okay, so now we go for the checkpoint question. Okay, so the question number 3 here is a problem solving question for free fall. That means the object is moving downward. Okay, so a ball is dropped from rest from the top of building. It hits the ground after 3 seconds. So what is the height of the building? Okay, so here you can actually using a symbol. Okay, so for the value given in the question. For example, the ball is dropped from rest. That means the initial velocity with symbol u is 0. And then here, time second to hit the ground, it will be t equal to 3.0 seconds. Okay, then the question now asks you to find out the height. That means the object distance or displacement here, right? From the top to the ground. So that means the object is actually dropped from top to the ground. But here is from the top of building. That means from here. So we may try to find the value of s, the moving distance of the object. So the height here can using the value of s. Can use the symbol of s here. Okay, so which equation suppose you need to choose? Okay, so here the question asks about s given u value u and t. Okay, this value we know already. So the g is always adding downward with negative sign, and value will be 9.81. Okay, so here you should choose the equation s equal to ut, right? Ut plus 1 over 2 gt squared will be this. So you substitute u at 0, t at 3.0. Then g negative 1.81 and t again 3 square. So you will get negative 44.145 meter. Okay, so the building height must be positive actually. Why here we get negative? Because the object is moving downward from top to the ground. Okay, so the building height you can just give as 44.145 meter. All the height must be positive. So the value you get here negative because of the object moving downward from top to bottom. Okay, so for B, what is the final velocity just before it hits the ground? So that means here we want to find out the value V. Okay, we want to find the value V here. Okay, again, we have the same given value, u equal to 0, t equal to 3.0, g equal to negative 9.81. Okay, so what formula you can use? V equal to U plus GT, right? So we want to find the value of U, of V. U will be 0. G 9.81 negative, time taken will be 3.0. Okay, so you substitute to this equation, then you can get your value. Okay, so here you get your velocity, negative 29.43. So that means the object is moving downward. So this is correct because the object is actually released from the top of the building. So this will be the answer. Okay, so now we go to our last question of the day. Okay, so we go for our question number 4. So the problem solving here will be the object throw upward. Just now the example is release downward. Okay, so here a ball is thrown vertically upward. So a ball you thrown outward with the velocity. So here definitely will be u now. With the velocity u equal to 20.0 meter per second. Okay, so how high does it go? Okay, so the object reach the maximum position. So all the kinetic energy will be converted to gravitational potential energy. So where the V will become 0 already because the kinetic energy now is become 0. So this is the value you should also know now. Again, the G added downward is always negative 9.1. So the question asks you about the S. Okay, so what is the formula you are going to use? Okay, so here without T, you should using V square equal to U square plus 2GS. Okay, so you have your value, V equal to 0, U is 20, G is 9.81 negative, and then you may get your S already. Okay, so it will be like this. U is given as 20, V you should know when reach the highest position, so the V will be 0, and G again is negative 9.1 because it's always added downward. Okay, so substitute in the equation you selected, substitute all the value. So you get your S will be 20.39 meter. So here you will get a positive value because the object is moving upward. Okay, so this is the answer for this question. Okay, so now we go for our last question, B. Okay, so how long does it take to reach the highest position? So that means now we want to find the time taken will be T. Okay, again, here will be a listed value we know already. So the S we get from question A just now. So what is the value of T? So here, the formula, you may choose U equal to U, V equal to U plus GT. Okay, so here will be the 0, U will be 20, G will be negative 9.1. Okay, so yes, Jiaying 9.915. Okay, it's almost finished. Okay, then T. So you just rearrange, you may get your T equal to 2.04. Okay, so this will be the last question for today. Okay, so that's all for my sharing about the lesson of subtopic of 2.3 today. Okay, so please click like and share the link of the lesson today for your friends so that there will be more people or more of your friends can get the benefit from my sharing today. Okay, so now I would like to share the link schedule for today to chat room. Okay, so thank you, Chia Yao. Okay, so share the link to your friend. Okay, so the link schedule for today's lesson already shared to the chat room. Okay, so please fill out the link within 30 minutes. Just after the class end today. Okay, so don't forget to follow the next physics classes with the class for Form 4 DLP will be as today, every Sunday, 8:15 p.m. So the next week will be presented by Cikgu Hasnitah for subtopic 2.4. Okay, and then the Form 5 class will be held on Friday, 9:30 p.m. is for non-DLP. Okay? Okay, so that's all for me. So bye-bye. See you next lesson. Okay, bye-bye.